Alright, so now let's look at them in parallel. So over here, I'm going to put 2 in parallel. Grab my voltmeter here. And let's do the same thing. Let's start out with equal capacitance. And our battery is maxed out. If I draw it down, let's see. So as I increase the voltage, each one of the capacitors is increasing in charge. Okay. Now let's see. Let's make C2 bigger. Remember, we reduced. Oh my goodness. I kept the voltage the same. I just made the capacitance, the capacity bigger. And now what's on this guy compared to that one? C2 is what? Has a lot more charge on it, okay? But the battery supplied this charge and that charge. So what can we say about the total charge supplied by the battery? Is it equal to the charge on each one? Right? Let's look at the voltage. All right, so 2 different capacitors, same battery. I'm going to grab my voltmeter, wire it in parallel. It says 1.5. All right? And my battery is 1.52. 1.5. So what can we say is a rule about voltage across parallel capacitors? They're the same. All right, so let's hop over here. So that means that V total, the total voltage across that branch, is equal to the voltage across one of them, which is the voltage across the second one. Now, Q is equal to CV. So let's make the CV substitution into our Q's here. So I'm going to just come down here, and I'm going to write in my substitutions. So Q total would be C equivalent, C total, whatever you want to call it, times voltage total. Q1 would be C1V1 plus Q2 would be C2V2. I didn't put a 1 there. There we go. What do you know about V total, V1, and V2? And mathematically, what can happen in that equation? Yeah, I can divide by the voltages because they're all the same. So then I'm left with the equivalent capacitance is C1 plus C2. What does that look like? Yeah, that looks like resistors in series, but it's capacitors in parallel. Wow.